Swan-Leavitt, where they provided us an entirely new method for measuring distances for stars as far as hundreds of millions of light years from Earth. So these Cepheid variables are something we now call standard candle stars. These are stars with known brightnesses that have distances that can be precisely calculated. And following the career and the work of Henrietta Swan-Leavitt, Edwin Hubble, who is the namesake of our fourth movement of music, used these standard candles to make an amazing discovery. Hubble realized that when he calculated the distances to many of these standard candle stars, they were far too distant to possibly be members of our own Milky Way galaxy. Instead, Hubble proposed these stars were members of new galaxies far beyond the Milky Way. This was the first clear evidence that the Milky Way is just one of countless galaxies in the universe. Since the time of Leavitt and Hubble, many of these distant galaxies have been discovered mostly by the Hubble Space Telescope, which of course is named after Hubble himself. Now, as I mentioned earlier, the Earth's atmosphere introduces all sorts of problems for telescopes on Earth. So you can put your observatory up on a mountain to eliminate some of the problems, but the way to really eliminate the atmosphere problem is simply to send your telescope out into space. So this is what astronomers did with the Hubble Space Telescope. It was launched into orbit in 1990 and is still in operation and taking data today, over 30 years later. Thanks to the Hubble telescope, we now understand the universe is filled with billions of galaxies. And each of these galaxies, just like our own Milky Way, contains billions of stars. Now, as we can see from these pictures, there are many different types of structures that the Hubble telescope has taken pictures of. We have nebulae, the giant clouds of gas and dust where stars are born. Increasing in size, we have galaxies, which are the large structures of billions of stars bound together by gravity. And on the largest of scales, we have this, which is my favorite image that's been taken by the Hubble telescope. So here, the telescope peers over 13 billion light years into the depths of space through a region of the sky less than 1/1000th the size of your fingernail. Each object in this image is not a star, but an entire galaxy. The complete image contains roughly 10,000 galaxies. This image, which is known as the Hubble Ultra Deep Field, conclusively shows, once and for all, that Earth and its cosmic neighborhood, including our own Milky Way galaxy, is just a small part of an unimaginably vast universe. So in the video for the fourth movement of music titled Hubble, we will leave the Milky Way and venture into deep space, exploring some of the amazing images of distant galaxies and nebulae that have been captured with the Hubble Space Telescope. Finally, we arrive at the present day of astronomy and reach our final movement named for Stephen Hawking. Now, in popular culture, Hawking is known for his many best-selling popular science books, his lifelong battle with Lou Gehrig's disease, and even a big-screen appearance in the 2014 film, The Theory of Everything. But in scientific circles, Hawking is known for his brilliant work in cosmology and the study of black holes. So a black hole is the final phase of a star's evolution, formed after the star has exhausted all of its nuclear fuel and undergone a supernova explosion, one of the most dramatic and energetic events in the universe. After the supernova, gravity violently pulls what is left of the star together, compressing the matter to infinitely high densities. The gravitational pull of these stellar remnants is so strong that nothing, not even light, can escape. So, if a black hole emits no light, how can we ever see these objects? Well, in the past couple of decades, astronomers have developed a few techniques to do just this. Black holes are really massive objects, and as such can exert a powerful gravitational influence on the orbits of nearby stars. So one way to identify black holes is to measure the orbits of stars nearby, and then calculate the presence of the hidden central object. So over the past roughly 20 years, a group actually just down the road from here at UCLA, which is led by Professor Andrea Ghez, has monitored the orbits of stars in the center of our galaxy and used these precise measurements taken over the course of nearly 20 years to show clearly that a monster black hole, nearly 1 million times more massive than our sun, lies at the center of the Milky Way. So this was a huge discovery, and Andrea Ghez was actually awarded the Nobel Prize in Physics in 2020 for this work. So we now expect that these supermassive black holes lie at the centers of most galaxies. And the extreme gravitational pull of these black holes influence the orbits of stars, as I showed in this animation, and also produce bright flares of light as nearby gas falls into the black hole. So in 2019, the Event Horizon Telescope collaboration presented a second method for observing black holes. This team published this amazing image, which was taken of the bright flares surrounding the supermassive black hole at the center of the nearby galaxy M87. So imaging the black hole in this manner was an amazing technological achievement and marks the first time ever that astronomers have directly imaged the shadow of a black hole. So we can't see the black hole itself, but we can see its shadow against the surrounding light. So there's one final way to observe black holes, and this is in my opinion, the most exciting, because this is actually the area of research that I specialize in. So if two black holes are bound together in a binary star system like we see here, the system slowly loses energy through the emission of gravitational waves. Eventually, the black holes slowly spiral in towards one another until eventually they crash together and merge, creating a larger black hole. So gravitational waves are ripples in the fabric of space itself caused by the extreme gravitational environments of black holes. Gravitational waves were first predicted by Albert Einstein almost 100 years ago, and nearly 100 years to the day that Einstein predicted their existence, we detected gravitational waves for the first time in 2015. So detecting black holes through the emission of gravitational waves is one of the newest and most exciting areas of physics, and is completely changing the way that we observe the universe. Black holes are points of infinite density in the mass of an entire star shrunk down to a size even smaller than an atomic nucleus. Unlike normal stars, black holes distort their surrounding space to extreme limits, forming something known as a singularity in space. Stephen Hawking spent his career studying these singularities and even believes the universe itself could have begun as a singularity similar to a black hole. So for our final movement of music for tonight, we will feature animations of black holes, the bringers of stellar death, alongside animations of nebulae, the clouds of gas and dust where stars are born. We place creation and destruction, life and death, side by side. Perhaps black holes hold the secrets to understanding the origins of our universe.